Today we are going to discuss a new chapter that is limits of accuracy. Okay. Now this is somewhat related to the previous topic, but not that much. Okay. Let's talk about a little background of this topic, that what exactly this means. Okay. So in the last sessions and in the last classes, we have been discussing rounding of numbers, right? Let's say that if we had 65, so we used to round it to 70. Or maybe if you had 72, we used to round it to 70, right? So this is what we have been discussing. In limits of accuracy, we need to find out the limits. By this I mean, let's say if a number or measurement, by measurement they mean sides of a table, length of a table, height of a room, something like that. If a number or measurement has been rounded, right? In the last class, we have been rounding numbers. This time we are given with a rounded number, and we have to find what possible values could that number have. It can be important to consider what possible values the exact value could have been. Okay. For example, let's say that if a measurement is 600 millimeters wide, okay? Now this is the rounded figure. This is the rounded figure to the nearest hundreds, right? You have been told that measurement of a width is 600 millimeters, but what could be the actual value? This is the rounded figure. If you're interested in the actual value, so you will say that, okay, it could be that the value is maybe 595, or maybe the value could be 596, maybe 597, so on. It could be that the value was 601, 602. Karte karte 605, but this would not be included, because if it was 605, the rounded figure would have been 610, right? So what we know is that the possible values could be all these, right? But less than 605 and greater than equal to 595. Do you understand?
Yes, I do.
So if we talk about the lower limit, lower limit is smallest value that would round up to estimated value. This is the estimated value. This is the smallest value which we can round up to get 600. So the limit, the lower limit would be 595 millimeters. And similarly, if I talk about the upper limit, it would be the smallest value that would round up to the next estimated value, right? Did you want, okay, let me write it down. Is the smallest value that would be rounded up to next estimated value. Now, what do we mean by this? Okay, now if 600 is the estimated value, if 600 is the estimated value, what would be the next estimated value? 610, right? 610. So if we have 605, we will get 610. 605 is the smallest value that would be rounded to get next estimated value. Okay? In short, just understand that whenever you have been asked to find the upper limit and the lower limit of a rounded figure, what you do is, you know that since it was rounded to the nearest 100, so this means that you will take 10 divided by 5, okay? 10 divided by 5 will, 10 divided by 2, sorry. 10 divided by 2 will give you 5. Now you have to do 600 plus minus 5. One value would be 605 and the other value would be 595. This is the upper limit. This is the
Why
lower limit.
why did we take 10?
Okay, we took 10 because the value is 600, right? The value is 600 and it has been rounded this way. So the next value, like the zero digit is coming on the 10th position. This is why we are, okay, this is not that, I'm not explaining how to do that right now. I'm just, I have not talked about that. Okay, I will talk about that in detail after this. Right now, I just wanted to give you a bit of a background, right? I did not write down the question. This is why you don't know what exactly the thing is. Just know that in this topic, in this chapter, you will be having rounded figures and you will be asked to find the lower limit and upper limit. This 10, I'll tell you from where. Okay. So is this okay? The basic idea, the basic concept.
Yes.
Okay. Now let's talk about proper examples and then you will get a better understanding. कि वो मैंने 10 कैसे लिखा था. Okay. Example number 1. A mass of 70 kg is rounded up to the nearest 10 kgs. Find upper and lower limit. Okay. Now again, we are discussing the new chapter, that is limits of accuracy. And right now we are just learning how to find the upper and lower limit, given that XYZ thing, in this case it is mass of 70 kgs, is rounded up to 10, nearest 10 kgs. Okay. You need to follow this, nearest 10 kgs. So we need to find 10 divided by 2. That is giving me 5. So my upper and lower limits will be calculated this way. One would be 75, the other would be 65, okay? Because I know that 65 is the smallest value, which when I round up, I get 70. And 75 is the smallest value, which when I round up, I get the next estimated value, that is 80, okay? So the lower limit is 65 and the upper limit is 75. Okay, anything that, okay, and obviously we will write it this way. Okay. Now, how do we define error interval? Okay, I'll tell you how to write it, but let's talk about error interval. It could be that the question says find the upper and lower limit. Obviously, question would be not this simple. We will talk about some past paper questions of this topic tomorrow. So you will get a better understanding the questions are a bit different or a bit difficult, right? But still, if you have been asked to find the upper limit and lower limit, and they want you to write down the error interval. Now we know that when we have interval, it is something of this sort. Since it is the mass, so it would be less than something and greater than something, right? And if we talk about these two things, so we know that it would be 65 and this would be 75. But you know well that if the value is 65, even then you will get 70. So you will write it less than equal to. But if you write down uh, mass is less than equal to 75, this would be wrong, right? Because if 75 is included in the range, you will get 80 when you round off 75. So this is how you write it.
Okay.
These are the two signs which we use. Anything that you have not understood so far?
Do we get this rounded up to the nearest 10 kg or 100 kgs every time in the question?
Sorry. Yes. Okay. Oh, we are talking about more examples. Don't worry. Yes, but yes, obviously.
Okay.
And yes, we will discuss some past paper questions where this would not be given. So I'll tell you कि हमने इसमें क्या करना है. Okay. Abhi we have just started, so let's keep things a bit simple. Right. So let's say we have 32 centimeters measured to nearest 1 centimeter. Okay, again, this is the value and it is measured to nearest 1 centimeter. Again, step 1 is to find the error, right? How do we find error? 1 divided by 2, that is 1 by 2, right? So this means that our error would be plus minus 1 by 2. And how do we find upper limit and lower limit? Upper limit would be 1 plus 32 plus 1 by 2. And lower limit would be 32 minus 1 by 2. This is going to give you 32.5. This is going to give you 31.5, right? So is this understood?
Yes, understood.
Okay. Let's say that the question is .4 centimeters measured to nearest 0.1 centimeters, right? Let's say this is the question. Again, step number 1, we need to find the error. Plus minus 0.1 divided by 2. 0.1, okay, because we were told. This will give us plus minus 0.05. And 8.4 plus minus 0.05 is gonna give you either 8.45 or it will give you 8.35. Now this obviously means that this is the upper limit and this is the lower limit, right?
Yes.
So let's talk about last example of this type. What is the upper and lower limit of 15.89 seconds measured to nearest 0.01 seconds. Okay. Again, nearest this plus minus 0.01 divided by 2. This will give us plus minus 0.005. Okay, do you understand why 0.005?
Oh, yes, I do understand.
Perfect. So 15.89 plus minus 0.005. 15.89 plus 0.005 will give you the upper limit, and 15.89 minus 0.005 will give you the lower limit. So this will be 15.895 and this will be 15.885. Okay. Says point. Okay. Any questions so far?
No, all clear.
Okay, perfect. Now, let's talk about this. Okay, now it could be that the question says calculate upper and lower bounds. Okay, statement could be this way as well of measurement, but obviously the content is going to be same. For example, A is 50, nearest 10. Obviously, again, we have been told nearest 10, the concept is same, only this word is different. 10 by 2 is going to give us plus minus 5. 50 plus minus 5 will give us 55 and 45. Okay. So again, this is the upper limit and this is the lower limit. And if you have been asked to write down the error interval, how will you write it down?
45 is greater than equal to the measurement is smaller than 55.
Yes. And this one, right?
Yes.
Okay. So you have understood this. Okay. What if the question is of this type? Seven 7.8 to 1 decimal place. What do we do in this case? 7.8 to 1 decimal place, right? What do we understand by 1 decimal place? 0.1, right? Divided by
Yes.
2, that is going to give me plus minus 0.05. Again, it would be 7.8 plus minus 0.05. So this is going to give me 7.85. That is the upper limit. And what would be the lower limit? 7.75.
75.
Lower limit, right? Any questions, anything that you have not understood?
No, clear so far.
Okay, perfect. So okay. A bag of flour has a mass of 1500 grams to nearest 10 grams. Find the upper bound for mass of 10 bags of flour. Okay, now this time the question is a bit different. They are not asking you to find the upper bound for this mass. They are saying find the upper bound for mass of 10 bags. Okay, so again, let's talk about the upper bound of this first. Okay, so error would be plus minus nearest 10 grams. So 10 divided by 2, that is going to give us plus minus 5. What is the upper bound of 1500 grams? Upper bound of 1500 grams would be 1500 plus 5. That is 1505 grams. Do you agree till here?
Yes.
So if upper bound of 1500 grams is this, upper bound of 10 bags would be 10 multiplied by 1505, that is 15050. Okay, is this okay? Have you understood this?
Yes, I understood.
Okay, perfect. Now, let's talk about another question that is a bit different. Jack is 1.8 meters tall, rounded to nearest, rounded to nearest 10 centimeters. Okay, now this is also important. This is meters and this is centimeters. Ella is 1.63 meters tall. Rounded to nearest centimeter. Okay. The question is, what is the smallest possible difference in their heights? Okay. Jack is 1.8 meters tall, rounded to nearest 10 centimeters. Ella is 1.63 meters tall, rounded to nearest centimeter. Okay. Right. Now I want you to tell me that how can we go about this question? What is the smallest possible difference in their heights? Like any idea, anything that you can guess?
Smallest possible will be, I guess, lower bounds of both Jack and Ella, and then subtract them to find the difference of the lower bound.
Okay, okay, let's see. Okay, let's see. Now, let's talk about the solution. Okay, let's keep one thing at a time. Let's talk about Jack. This is for Jack. We need to find the error, but we cannot find the error directly. Like we have been told that it is rounded to nearest 10 centimeters. Okay, so error is plus minus whatever it is rounded to divided by 2. This is in meters, this is in centimeters. We need to do one thing. Either convert these meters to centimeters or convert these centimeters to meters. So let's say 10 centimeters are 0.1 meters, right? Do you know how to convert these?
Yes.
Okay. So 0.1 meters, this will give me plus minus 0.05 meters. Okay, so this is important. Units are important. Okay, so this is clear. Okay, next, let's find the range for Jack. So it would be 1.8 less than equal to 1.8 minus 0.05 and less than 1.8 plus 0.05. So what do we get? We will get 1.75 meters less than equal to 1.8 meters less than 1.85 meters. Any questions?
No.
Okay, this is what we are getting for Jack. Okay, so Jack की जो height है ना, it could be 1.75, 1.76, 1.79, it could be 1.8, it could be 1.82, 1.83, 1.84, but not 1.85. Okay, so this should be clear. Okay, so this is what we have for Jack. Let's talk about the other one, that is Ella. Okay, so Ella is 1.63 meters tall, rounded to the nearest centimeter. So 1 centimeter equals how many meters? Do you know this? We will do 1 divided by 100 to get the figure in meters, and I am going to get 0.01 meters. Yes, do you agree?
Yes.
1 centimeter. Let me explain this as well. Okay, so we know that 1 meter equals 100 centimeters. If you are interested in finding out 1 centimeter equals how many meters, we will just cross multiply. 1 equals 100x and this would be 1 by 100, that is 0.01 meters. Okay, now for Ella, the error would be plus minus rounded to the nearest centimeter, that is 0.01 meters divided by 2. This is giving me 0.005. Okay. And what about Ella's range? It is going to be, I'll write it here with pink color. Ella's range would be 1.63 minus 0.05 less than equal to 1.63 less than 1.63 plus 0.005. Can you tell me what exactly are you getting when you do this?
For the lower bound, it is 1.625.
1.625. Okay. And
for the upper bound, it's 1.635.
1.635. Very well done. Okay, perfect. Now we have to see. Okay. The question was, what is the smallest possible difference in their heights? Okay. Now, you said that we'll take their lower limits. Okay. But let's say if we take their lower limits, this is 1.75 meters. This is 1.625. Find the difference. 1.75 minus 1.625. What are you getting for this?
0.125.
0.125. Okay. And what if you think about choosing some other combinations? What will you get in that case?
In that
For
case, it would be
for
like the upper bound.
For example, now look. Think of it on a number line, okay? Think of it on a number line. I'm sorry, it's getting very ingested. Okay, this is 0. But all the values are positive, so let me write 0 here. Okay, this is 0. Now, we have, let's say this is 1.625. Then let's say this is 1.635. Let's say this is 1.75 and this is 1.85. Which are these four values? This one, this one, this one, and this one. Okay. Now, what we have calculated right now is this and this. But obviously, this shouldn't be the answer. We can do, this is for Ella and this is for Jack. One combination was this, other one could have been this, but the correct choice, the smallest possible difference would come if we choose this and this.
1.635 and 1.75?
Yes, very good. Okay, so 1.75 minus 1.635 is going to give us what? 0.115 meters, right?
Yes, 0.115.
So this is the answer. 0.115 meters. Either you can convert this to centimeters or you can keep in meters. That is completely your choice. But if we have been working in meters, obviously we need to stick to meters, right?
Is there any rule for do we have to draw a number line every time to see what is the smallest possible difference?
Yes, because look, every time, obviously, no, not necessarily. But yes, for your reference, just so you understand things in a better way, you can just plot a rough line and then do it this way. Right?
Okay.
Okay. So anything that you would like to ask? Anything that you have not understood?
No, it's clear.
Okay, so we will talk about more examples tomorrow. I will just